All right, thank you so much. Python students, welcome to Module 2. The emphasis on Module 2 is the content inside of chapters 5 and 6 inside of Computer Scientist. And by now you've probably adapted to a couple things. You're using the Runestone compiler. And students made the effort to learn the Atom compiler in the first week. Let's just say that the value of understanding Atom is that it's out there, and it's what professionals use along with utilities like VS Code. And it takes a little bit of configuration. And what I found, though, is for this class, it's good to know that Atom is out there, but the value of the Runestone compiler is so good that we're going to probably use Runestone for everything. So moving on, you'll have the chapters 5 and 6 to read over. And then for every module inside of our course, you'll have 4 programs to submit, which means that for every module, you'll have to choose 4 programs from the reading and go ahead and work on those 4. And that provides a little bit of diversity because some of you may be very graphics inclined, i.e. you're motivated by visual computing. So assignments like this are going to light up and are going to attract you. Some of you are more statistic or more data textual. And so more of the data science-y content may grab your eye and challenge you. And these are both very respectable challenges. This is a chance to explore what interests you the most and also to give you credit for whatever it is inside of Python draws your interest. But just keep in mind that only 4 short programs are needed. So you don't need to do 4 from every chapter. It's just, if one chapter really works for you, then focus there. If another chapter is challenging, do less of it. Do more of the stuff that you're good at. I'll admit any day that the Turtle Python stuff has its own, specific challenges, and that there are other folks who may smile on statistics, and there are other folks who might smile on visualization. I say embrace both. So I want to go through the Module 2 content, which will be the readings will be right here, and then you'll link to the chapters here on Runestone. So let's get going. So chapter 5. It looks like this, and it deals with modules. Now, the secret to modules is that anytime you deal with a module, you deal with the import statement. And once you import a module, then you inherit all of the capabilities of that module. So, for example, in this exercise, we're going to leverage the power of the random module. And so whenever you grab random, you have the ability to generate random numbers, which is a big deal. Generally, a random number occurs between 0.0 and 0.99999, and it has many items of precision. The item it'll never be 0 because it's never an integer, and it will never be 1 because both 1 and 0 are integers. And so it's always dealing with that in between 0 and 1, and there can be a lot of space between 0 and 1. But generating a random or a pseudo-random number that has the look and feel of something random is extremely valuable to operations and encryption. It has a lot of value to simulation. And so when we're in the early stages of teaching and learning programming, the random number is valuable to us. So let's jump into this first one. And I think there are 2 things to look at. One is the import, which is we're going to grab the capabilities of the random number generator. And then if you scale down a little bit, then we're going to take advantage of a for loop. Now, for loops are great things to memorize because as you go forward into computer science, for loops give you the ability to do something many times. So if I were to say, I want to do something 10 times, then I could run a for loop that would operate 10 times and it would repeat 10 times, such as you do here. So we don't actually code all of these. What we do is we ask for a print statement to run 10 times, i.e. from here. And that creates some special capabilities later on. So the for statement always has 3 components or two components. And so the two components it has here is it creates a range of 10 values, and it's going to operate 10 times. And then what it does is it creates an index. And so every time that we run the for loop, so it's going to run 10 times, and every time it runs, the value of counter is whatever is inside of that operation. Now, what we do here is, so you could actually print counter just to kind of unpack a little bit, and let's go ahead and do that. So what you'll see here is counter is the number or the time that you repeated it. So for the first repetition, you would say you would simply add these two together. And one thing you could say is this is the time that I am repeating it. So on the first go, and it always begins at 0 because mathematics loves zeros. 0 is credit. The first time that we run it, it's repetition 0, and that's the value that we generate, i.e. a random. And so in the second time, the repetition is number 1, even though it's the second time, it is going to print this. So now that you have that under your belt, you understand that the counter is a very valuable value that tells, well, this is the time, this is the repetition number. And we usually refer to that as an index. So at index 0, and let's just bring that back. At index 0, we are getting this result. And at index 1, or the second time that we do it, we are getting this result. So print a random. So that's very good. Now, if I wanted to take this apart, and why don't we just kind of cut that, it's pretty interesting that a sequence of this length is going to actually identify, now I'm not printing out a random, I'm printing out counter. So you can see that within the basic for loop, there are two variables. There's a limit and there's an index value. And so what we do is we tell Python we want to run a loop by indenting on these lines. So the for loop will continue until we have the indent. And you notice after it's finished, we can erase the indent and then it will stop using the for loop. Now, everything that gets done within the for loop is created very temporarily and then destroyed. So if we create a variable that operates within and then we want to print that's an L, by the way, and we wanted to print that, we're going to we're going to create this variable that will be very temporary. And why don't we make that into counter? And that variable X and L, they exist very temporarily. And by the end of the for loop, they'll be destroyed. So they won't be accessible later. So let's kind of go down here. And we'll say, well, go ahead and print X for me. And it won't actually print it. It'll leave it alone. So you realize there's been very little difference between these runs. Once the for loop is finished, everything that get done that was finished inside of the for loop is destroyed unless we connect it to, for example, a result. And maybe we'll create an empty result at the beginning. And we'll say, well, those are going to get eliminated, but why don't we add the result is equal to and then we'll just kind of print the result later. And I hope that what I'm doing, I hope I don't mean to go too fast, but I do want to say that the great thing about this Runestone compiler is it gives you the chance to have some experiences and make some mistakes. And so that print statement is given to us at the very end of the output because I have this. But if I eliminate this, it's very hard. So for example, if I eliminate this, ultimately it won't run. And so that 0, that's my result. You realize that result never gets incremented that way. And so let me just kind of bring that. So there's a little bit of data privacy inside of the for loop. It means that what you build inside of the for loop exists very temporarily. And it also exists for that repetition. So when I've done it 100 times, which is kind of cool. It also means that each time my for loop repeats, it destroys the data from the prior run. So it creates a very temporary calculation for each of the rotations of the for. So that gives us a lot of freedom moving forward. And we've mined that for some extra value. Here, what it wants you to do is, can I repeat something, 3 times? And the answer is, you betcha. Can I repeat it, 33 times? That's great. So I want to invite you to make some experiments. And then also, how many counters do I use if I do this? And then what is my initial value? So this is the simplistic for. It's very valuable. I use it all day long. Now, I want to go to the next one because and this is the 5, this is inside of the exercises at the end of 5. You can see here that we're going to import the math package. And then what math gives us the ability to do is a lot of the, for example, well, it gives us a lot, but here it's calculating the hypotenuse, which is the third side of a right triangle. And you'll probably remember hypotenuse from geometry. It's such a valuable concept. You actually can use hypotenuse in very advanced data analytics. And that's simply because if you have one value and you have another value, if those values have a 90-degree triangle at the bottom, i.e. they fall within a graph, then you'll be able to locate the third side of the hypotenuse. So that, and I don't mean to talk about that quickly. I'm sure we can just go. We can quickly do a graph. A quick hypotenuse is really that missing side after we've located this side, and we can assume that there's a 90 degree. Now, 90 degrees are very human-made things. So when you have a graph and you have an XY axis, you have a x-axis at the bottom, you have a y-axis, then a right angle is something that you and I can make on our own. They may not occur in nature. I know a lot of spheres occur in nature. Not a lot of right angles occur in nature. That's a human-made thing. But we can make 90-degree angles nicely within a graph. So it means that if we have this length and we have this length, we can estimate the value or calculate the value of hypotenuse. And so that occurs within our hypot. And so we'll feed in side 1 and side 2, i.e. P and B in this illustration. And from there, we can generate that outcome. Now, if we wanted to feed this is kind of fun. We could technically feed this into, here, let's just kind of steal this and feed this into our top app right here. And let's kind of, now let me run this because it's going to result in a error. And it's like, wait a sec, I don't know what math is. And so you're thinking, well, that, my good friends, is the name of the Python module that I depend upon to get those results. And this is why I love error debugging. It's like, well, you use that math tool right there. But if Python doesn't know about it ahead of time, then it can't go ahead and use it. Now, it will, and this goes to our second point, which is about functions. Functions guarantee that if you, and this is a function, if you go ahead and use the same inputs, i.e. the same parameters, and in this case it's side 1 and side 2, you'll always get the same result, which in this case is hypotenuse. So that result is always 5.0. This is the classic. And if we go 2, 3, these are classic kind of, and so we'll always get that same value. So good, I hope that's helpful. And what I encourage you to do is to go ahead and review this video, slow it down. You'll probably get a lot of it the first time that we do it together. And then I recommend that you watch it, just let it wash over you, let it happen, and then go back and say, wait, you lost me here. I'm going to study that some more. So some big ideas. A, the use of modules, the use of functions, and then the use of for loops. And that will help to augment what you already know how to do in terms of variables, which are the sacred. Variables are big. If we can reduce something to variables, boom, we're enjoying programming. So let's go from there. Let's scale up to chapter 6, where we're using a classic visual formation inside of Python. It's called Turtle. And Turtle is a little graphical item that will go ahead, and that's the turtle right there. And that turtle will move around and print things to the screen as we go forward. So firstly, I'm going to import the turtle, and that gives me the liberty to do stuff with the turtle. So I can set up the window and its attributes, and this won't get read because that's a comment. And so firstly, we establish a windowing environment, and then we can establish the background. Maybe we say, maybe we change that a bit. And then it will go ahead and automate, because you and I have created a range. So we've created a range of 1, 2, 3, 4, 5, and maybe we can, can we go higher than that? Let's take it to 11, and he'll begin to work. Turtle goes, and I I think he's going linearly. Hey, come back. Where did you go? And I think it's where we start to move and how far we go. Now, what I like is that he doesn't necessarily know what to draw, but the reason why he knows what to draw is because we have this feature called Draw Square. And so we're going to call this particular turtle that we built, and then we're going to draw a square. And so it means we're going to draw 50 squares. Now, if we wanted to only draw 2 squares, let's take him out of his misery, and maybe we can cause it to break. Is he still working? I think he may be just, and maybe we can just refresh. Yep, that's good. And so I'm sorry, I'm just starting fresh. Now here I was drawing 5 squares. Why don't we just draw 2, and then, and we'll start again with our black background, and feed in some common color names. So he's finished there, and he drew his 2, and that was his limit. And I could establish a limit here, and maybe he could draw, 4, and I could substitute that range to a limit. Great. And let's go ahead and run that limit, and he'll just go ahead, and I think he speeds up per requirement. But what this means is, and And if I set my limit down to 1, again, I'm just kind of showing off the for loop because I love for loops. And now he's finished. So it means that he's going to run the draw square feature, right? And this is called a function. And you've indented here, and you've indented into that for, and they run a for loop inside of the function. How cool is that? And so they're going to run the draw square for every element within the limit. And then what I feed it is I feed it the turtle. Alex is the turtle. And then I go ahead and I feed it this size. And so it's going to go forward and then left 90 degrees according to size. And I think what you could probably do is, you could probably say size is equal to SZ times 2 if you wanted to, and then don't use SZ but use size. And let's kind of hack it a bit. And that creates a bigger square. And what if we gave it 10? And I don't want to overdraw. So already you're hacking the capabilities of draw square. Now, draw square is a human defined feature, and you have the liberty to, that's not going to adjust things. So you have the chance to make things, and why don't we just, and why don't I just kind of say used to be draw square, and that's just a note to self. And so that's good. Now, I think we can also, adjust the pen size. And, why don't we try to, create a yellow. Do they have baby blue? I'd like to change that. It's a favorite color. So that's great. We'll get him working on that, and maybe we can create so this is a good discussion because you guys are using the power of your variables, and you're using your for loops. And it just so happens this for loop helps to draw the square using the capabilities of the turtle. And you're also running a function. And this is a function. And every time you run it, it'll, and I think that's the size. Why don't we create a really small triangle? The function will always take parameters. So in this case, there are 2 parameters. And it's feeding in those 2 parameters. And the parameters are specified by what's called the method signature, which is within the name of the function, or the def, if you will. And, can I make his size, can I make it size bigger here? That's fine. Ooh, that's cool. And I think it respects it seems to be drawing over itself. And I think it's built on the forward movement. So already, these executions are parametric. They work within inputs that you give it. And I think it's just advancing. And I think it's built on the forward variable. So, so you're working with for loops. You're working with variables. You're working with functions. And I can change the name of those functions easily, so long as I'm kind of organized. I know what's happening. And then I'm using the library of the turtle, and I'm working within the parameters of the turtle. So let me say this. If I were to expose the turtle method in Python, and why don't I try to Google it, turtle Python parameters. I could probably look at the documentation of Turtle and realize that Turtle has a number of internal functions that operate in the same way as the functions that you have here. Where inside of Turtle also has defs, or it has functions inside of it. So let's go forward. So this is just the documentation to Turtle, just in case some of you who will probably really deck it out, you'll be classic Southern California, just having to customize your lunchbox and really make it do what you want it to do. So this is a fun chapter. It gives you a couple of examples, and I invite you to, rearrange, the parameters, work within the parameters and study the ramification of your parametric differentiation. Change things, see what it does, right? This is the way that these API writers intended. This is going to be a fun one. I know when I look at your assignments, I really enjoy looking at all the cool results that you have. Look at, you're really getting Turtle to do it, to earn his lunch money. Now, what you should do is you should select all, copy, then put that into your document, and then go ahead and then screenshot. And here I'm using my Mac, so I believe I go and then you should screenshot this, and so you should copy paste this into your document and then screenshot this, and then that's going to be awesome for me to read. I just get fired up reading all your assignments. All right, best of luck.